What's up, guys? Welcome back to the same old spot here. This is lesson 3 for unit 2. There's only one concept for today, and it's the concept of a biconditional. We're going to start by recalling and reviewing what we did last lesson in lesson 2. And if you forget, that's where we had conditional statements, and we arranged the information in the conditional in 4 different ways. Analyze the truth values as well. So let's go ahead and recap last lesson in this top little chart here. So there's a statement that's being made at the very top. It's not a conditional statement. It's not an if-then statement. It's got to have those words to be a conditional statement. It's just a statement that says a straight angle is one that measures 180. Now, I need to identify for my conditional statement a hypothesis and a conclusion. And then I need to throw the words if and then in there. So let's go ahead and do that. So a straight angle. The first part of the statement, that's going to be my hypothesis. And remember, we called that P. The second part, measuring 180, the second little piece of information here, that's going to be my conclusion. We'll call that Q. So when I arrange this stuff into a conditional statement, remember the symbolization for that was like P arrow Q. If P happens, Q happens. We'll talk about whether it's true or not. So let's go ahead and make this an if-then statement and just phrase it so the English sounds right. I'm going to say, if an angle is straight. That's how I'm going to kind of phrase this. If an angle is straight, hypothesis first, then, now my conclusion, it measures 180. And let's think about whether that's true or not. So if it's a straight angle, does it measure 180? Yep, that's true. We learned that last unit, or reviewed that last unit. Okay, now let's do the converse. So remember, the converse is when you just flip the statement. So Q comes first, then P. So I'm going to flip this, and I'm going to say if an angle, I'm going to keep that part with the hypothesis here, if an angle measures 180, then it is straight. Okay, and let's think about whether that's true or not. So if an angle measures 180, then it is straight. That's true. 180, it's got to be called a straight angle. Now, before I even go any further, remember that trick that we learned last time with the truth values. This is so useful. I can't stress that enough. The conditional and the contrapositive. If you're looking at a chart way of organizing it, it's easy to remember because it's the first and the last, but it's the conditional and the contrapositive. Those always match. Same thing in the middle. The converse and the inverse, those always match. So these two in the middle both are true, and the first and the last are both true. That was my fun. So that's going to be important today. These are all true. Inverse, let's just go through it real quick. You don't flip it, you just make it negative. Okay, so this first, come back to the conditional always. Keep the order the same, just insert the words not. If an angle is not straight, then it does not measure 180. I write entirely too big. The contrapositive, you change everything about the conditional. You flip it and you make it negative. So that would be not Q, not P, symbolized. So I'm going to say if an angle does not measure 180, a lot of writing. Ooh, bleeding over here. Then it is not straight. So sorry if that's hard to read. That's all review. None of that is new. Now, again, remember the truth values. It's way easier to tell when the nots are not involved if it's true or not. Okay, that leads us to today. So a biconditional. This situation right here with this statement and writing all 4 statements that go along, conditional statements that go along with it, this can be made into what's called a biconditional. There's two conditions. Bi means two. So a biconditional can be written when both the conditional and the converse are true. So if the conditional and the converse are true, that basically tells us that all the statements are true because we know that they go together. So basically all the statements are true. When all the statements are true, you can write a biconditional. And to do that, you take the hypothesis and the conclusion and you separate them with the phrase if and only if. I mean, it sounds kind of complicated, but it's not really, you guys. It basically just means that like this part and this part have to go together. They always go together. There's no ifs, ands, or buts about it. For example, if an angle is straight, it absolutely measures 180. If it's 180, it's straight. Those two things are always correlated. They go together always, two conditions. There's a symbol for if and only if. If you ever see it, it's IFF. If and only if. Kind of like a random geometry thing there. So let's go ahead and write the biconditional from this statement. A biconditional isn't a conditional statement. It doesn't have if, then. You just take the hypothesis and the conclusion, and in between them, you put if and only if. Make it make sense. So I'm going to say an angle is straight if and only if, there's no way around this, it measures 180 degrees. Two conditions, they got to go together. Okay, let's practice. Write the converse in the biconditional for the following statement. If a biconditional cannot be written, provide a counterexample. Okay, so they gave me the conditional statement. I just want to write the converse. Okay, so the first part of the chart. I want to flip it and write that statement. So if, here's P, here's Q, flip it around. If, and I'm going to say two segments. I'm going to keep that part there so it kind of reads a little bit better. If two segments have the same measure, then they are congruent. And I'm going to abbreviate here for lack of space, congruent symbol. Now, that's the converse. I can write that no matter what. I can only write a biconditional if everything is true. So I have to go in and look at truth values. So let's see, the conditional. If two segments are congruent, they have the same measure. That is true. What about the converse? If two segments have the same measure, then they're congruent. That's true. So guys, basically, if the first two are true, again, we know all of them are true, and everything has to hold true for us to write a biconditional. That just says that like these two pieces, these two conditions, always go together. So what I'm going to do is basically come to the conditional statement. I'm going to remove if, remove then, and in between the two parts, I'm going to write if and only if. So I'm going to say two segments are congruent, and I'll use the symbol here, if and only if they have the same measure. There's no way around it. Those two pieces of information always are correlated. Okay, let's do one more. So this next one, they give me the conditional. I can write the converse no matter what. It's the biconditional that I can only sometimes write. But let's go ahead and flip this thing. So let's see, P. Oh good, this one isn't mathy. This is a little bit more fun. So I'm going to say, and the conditional is, if you travel legally, keyword, from the U.S. to England, then you have a passport. So let's write the converse. If you have a passport, then you travel legally from the U.S. to England. Clearly one line is not enough for my massive handwriting. Now, let's analyze if these are true, because if something is not true, I cannot write it biconditional. Conditional statement. If you travel legally from the U.S. to England, you have a passport. Yes. To travel from country to country, you have to have a passport. What about the converse? If you have a passport, then you travel legally from the US to England. That is not true. Just because I have a passport doesn't mean I'm going to England. Maybe I'm using it to go to any other country. So that's false. If any one statement of your 4 is false, you cannot write a biconditional. Those two things, that hypothesis and that conclusion, are not always linked together. Okay, so sometimes that happens, just don't write it, you can't. Okay, last example, short and sweet here. We're going to work backwards in this example. So we're going to do the exact opposite of what we just did. We ended with writing a biconditional, if we could, on these first two examples. This one, they're going to give me the biconditional, and I have to split it into the conditional and the converse. So let's see if we can do that. And remember, biconditionals are not going to be if-then statements. They're going to have if and only if, separating the hypothesis and the conclusion. So here we go. Now, basically, you just have to identify the two parts and then put if and then in there. So I'm going to remove if and only if, and I'm going to say if then. And let's just make sure it makes sense. So if you get an A+, then you got a 98% or above. Yeah, A+ is a 98%. 98% or above is an A+. Those two conditions always are connected. So that's where the biconditional came from. So if you get an A+, then you get, we'll say get, a 98% or above. Remove if and only if, put if then in there. And the converse, then you're just going to flip the conditional around. So I'm going to say if you get a 98% or above, battery. Then you get an A+. All right, that's it.